We're going to look at two examples here of writing equations for precipitation reactions, and we're going to do this using the solubility table in order to predict the products. So you can find a solubility table in your textbook or online, but it just shows you some rules about some positive and negative ions that are either generally soluble or generally insoluble, and then the exceptions to those rules. And so we'll look at how to use this table as we go about trying to write a chemical equation for this reaction here. So our first example, we're mixing potassium sulfate with strontium nitrate, and we want to predict, does a reaction happen? And if so, what are the products? So if we have two things that are aqueous, they're dissolved together in the same beaker in water, and that means that we've got all these ions swimming around with each other. So we have potassium ions swimming around, we have sulfate ions swimming around in there, strontium ions in our solution, and nitrate ions in our solution. And those things are all moving about in there. The potassium sulfate, this says it's aqueous. We already know that it's dissolved, so we know it's soluble. So it's not going to be a product of our chemical reaction because those two ions don't react with each other. And we can see this if we look at the solubility table. If we look at potassium and sulfate, if we look at the rules here for sulfate, they're generally soluble, and there are some exceptions to that, calcium, strontium, barium, and lead. But potassium is not one of those exceptions. There's also a rule for potassium here that says that it's always soluble and there are no exceptions. So there's two ways we could double check to know that potassium sulfate is soluble. So again, strontium nitrate, we know that's soluble, that's dissolved in our beaker, all those ions are swimming around. What we want to look at is when we form a product, now all these things are together, we have a potential for the positive ion from this compound to react with the negative ion from this compound, and also a potential for the negative ion from this compound to react with the positive ion from that compound. We won't get two positive ions together because positive and positive do not attract each other. The same thing with negative. The two negative ions are not going to attract each other. However, I have two potential products. One of them would be strontium and sulfate. So strontium, we said, was 2 plus, and sulfate is 2 minus. So a potential product there would be SrSO4. And I'm writing that chemical formula based on the charges. I'm not going to worry about balancing the chemical equation at this point. I'm just going to worry about having a correct chemical formula based on the charges of the ions. So strontium sulfate would be SrSO4. So now I want to go to my table and find out, is this something that's soluble or not soluble? Strontium sulfate. So if I look at sulfate, I said that those were generally soluble, and strontium, though, is one of the exceptions. So if it's generally soluble, but strontium is an exception, that means that strontium sulfate is going to precipitate, come out of solution. Those two ions are going to be attracted to each other, and they're going to form a solid in my solution. The other two ions that I need to look and see if they potentially form a product are potassium and nitrate. So if I look at potassium and nitrate, potassium has a +1 charge, nitrate a -1. So if I look at a potential chemical formula for that, it would be KNO3. So +1 and -1 balance each other out. And if I look at my solubility rules, potassium, we said, is always soluble with no exceptions. And the same thing with nitrate. Nitrate is always soluble with no exceptions. So I know that this is not going to form any kind of product. So that's just aqueous. So if I had two products that were aqueous, that would mean nothing happened. That would mean I didn't form any product. I just have a whole bunch of ions floating around in solution. But in this case, I did form a product. I have strontium sulfate and it's a solid. And so I do have a chemical reaction here. So my product is strontium sulfate. And then I can go ahead and balance my chemical equation. So one of the rules was if we have polyatomic ions, that's something we can look at first to balance. If I look at sulfate, SO4, I have one SO4 on this side and one SO4 on this side. If I look at nitrate, I've got two nitrates on the left-hand side, but only one nitrate on the right-hand side. So if I put a coefficient of 2 here, now I would have two nitrates. And that also changed my number of potassium. So now I've got two potassium on the right-hand side of the equation. So if I look at the left-hand side, I actually already have two potassium because I had a subscript of 2 right there. So 2 potassium. And strontium, I have one strontium on the right-hand side of the equation and one strontium on the left-hand side of the equation. So that's balanced. So this is my balanced chemical equation, and the product that I formed was solid strontium sulfate. All right, let's look at one more example. So now we look at sodium nitrate reacting with magnesium sulfate. So we need to see what are the potential products of this reaction. They're both dissolved in solution, they're both aqueous, and I have the potential for the positive ion here to react with the negative ion over here, and the negative ion from this compound to react with the positive ion from this compound. All right, so let's look at the sodium and the sulfate. Sodium has a 1 plus charge, and sulfate, if you can't remember, you can either look at the magnesium and work backwards, or you can look at your table of polyatomic ions. That's a 2 minus charge. So to write a balanced chemical formula for that, I would need 2 sodium for every 1 sulfate. Oops, Na2 SO4. And I'm not going to look at yet what, if these are solid products or if they stay dissolved in solution. First, I'm just going to look at what are the chemical formulas, and then I'll consult my solubility table. So the next one is magnesium and nitrate. Magnesium has a 2 plus charge, and nitrate has a 1 minus charge. So if that forms a compound, then the correct chemical formula would be Mg, and I would need 2 nitrates to balance the 2 plus charge of the magnesium. All right, so now I need to see, do either of these actually form a solid and precipitate out of solution? So I'll consult my solubility table. Sodium and sulfate had rules that say they're always soluble with no exceptions. So I know that this is not going to form a product, it's going to stay dissolved in solution. Magnesium and nitrate, if I look at nitrate, I had a rule that said that is always soluble with no exceptions. So this is also going to stay dissolved in solution, and it will not form a solid product. So here, if I have a bunch of ions dissolved in solution, and then nothing happens, I go on this side, I still have just a bunch of ions dissolved in solution, I didn't form any solid liquid gas or anything like that, then I don't even have a reaction. Nothing happened here. So I would write no reaction, and these mixing sodium nitrate and magnesium sulfate would not produce any result.